Started by you, let everyone know they are being recorded. So, successive differentiation. If you have y is equals 3x squared plus 2x plus 5, then dy dx is equals to 6x plus 2. This derivative can again be differentiated. The process is called successive differentiation, meaning that if you differentiate dy dx, then you get the second derivative, which is represented by d squared y. Some of you write this. What is that? There's nothing like that. Make sure, right? There's nothing like that. So the second derivative then is represented by this. Now they say if you differentiate now the second derivative, you get the third. And if you differentiate the third, you get the fourth derivative, and so on. Now, in some cases, we soon come to end up getting 0. In others, the process goes forever. What they are saying is, for example, if you differentiate this again, you get 6. If you differentiate 6 again, you get 0, right? That's what they're saying. But some process, they go on and on. For example, if you differentiate sine and cos, you'll differentiate your whole life and you will never get 0. Does it make sense? Does this statement make sense?
Yes.
Yes or no? 3 yeses. I move forward.
Yes.
Yes.
Guys, 3 yeses not from the same person.
Yes,
ma'am.
Yes.
Thank you. Danko. So the symbol d to the power of ny dx must not be confused with the power. Does it make sense?
Yes, ma'am. It makes sense.
Thank you. Now they say, for example, if y is equals to x to the power of 6, dy over dx is equals to 6x to the power of 5. The second derivative of that is that you differentiate this one again. Now they are saying to you, dy over dx all squared is the same as dy over dx times dy over dx, but not the second derivative. They're just emphasizing that. Now, there's a different notation as well, where you use prime. Did you learn prime in Math 1581?
Yes, grade 12, I think.
Yes, prime. F prime, it means the first derivative. F prime prime, it means the second derivative. There's no, for the seventh derivative, normally they'll write a number. I forgot Roman figure, the seventh. How do you write a seventh? I forgot. Let's say the fifth one, something like this. A Roman figure in 7. They don't go 1, 2, 3, 4, 5, 6, 7 like this. So from f to the power of 4, it means the fourth derivative, like that. Or in a Roman figure term. Are we all together? I think I'm.
Yes.
Yes, ma'am.
Danko.
Yes.
Okay, I think this session will be very easier because it's just what you know. It's just what you know. So then we go and say example 1. So here, they are just showing you that in a prime form, the third derivative will be like this. Now here they want you to find the third derivative of y is equals to 10x. How many times are you differentiating in this case?
3 times.
3 times.
Right. So let's start. dy over dx will be equals to what? We shall keep quiet because some of us, we forgot the standard derivative function. Like me, I'll keep quiet. dy over dx is what?
3 sec squared 3x.
3. Yes. 3 sec squared 3x. Are we all together or someone is confused?
We together, man.
Together. Then from here, the second derivative, d squared y over dx squared is equals to Don't copy from the textbooks, guys. Let's remind each other. So if we have 10 of x, the derivative dy over dx of 10 of x is equal to what? Sec squared x, isn't it?
Yes.
Now, if we have sec of x, what is the derivative of that?
It's
sec
sec
x tan x by 1.
It's what?
Sec x. Sec x tan x.
Tan x. Thank you. So now we have tan of okay, I just want to simplify it because sometimes we forget. So we know dy over dx, so meaning that it's sec squared x. So in this case, because we have f of x, so this is sec squared 3x times the derivative of f of x, which is 3. So then this is equals to 3 sec squared 3x. Thank you. Now, dy over dx. Sorry, squared, the second derivative. What do we do to the above first? Do we know the derivative of sec squared? Guys, do you know the derivative of sec squared?
No.
Hello. So what do we do? What can we do? Think, guys. Maths is there to make you think. Critical thinking, which is one of the skills that are required in this fourth industrial revolution or revolution, whatever it's called. Yes.
I think should the two there, the sec squared, the two we must take it out and bracket the whole thing and then put the two outside.
Danko. So let's do that. So this is equals to 3 open brackets sec 3x squared. Are we all together in this boat?
Yes, ma'am.
Yes.
Danko. From here, then we can go and find the second derivative of it. So this is equals to, now differentiate. Now you know the derivative of sec. And the function there is not x. It's actually 3x. So you can do the math. Let's do the mathing. So this is equals to what? You guys said you know the chain rule. You did it last week. And you made me spend time on it.
This is gonna be
6.
One person,
6.
please. Where did you get the 6? Step by
It's a
step.
function.
Remember, it's a class. This is a class. This is not an exam. Class. So step by step.
First, I'll differentiate the outside by saying 2 multiplied by 3.
Thank you.
Then I get a 6. 6 sec 3x. And then
Okay,
then
let's do this first before you multiply the 3. So then this becomes what?
this becomes sec 3x because it's the power is a 2 minus 1.
Thank you. Sec 3x, it's a 2 minus 1 time. Guys, you need to remember, you need to be a grandfather that can explain to your grandchild one day. Don't say 6 and then the child doesn't know where to get that 6. Okay, then
Then we differentiate the inside, which is sec 3x. It's going to be sec 3x times tan 3x. And then also differentiate the 3x, which is going to give a 3.
are we all together, guys?
Ma'am?
Yes, ma'am.
3 next to the 6.
Okay, let's start with one who said about the 3 next to. I didn't hear anything after. Let's start with that person.
Ma'am, what you wrote now, I think it's supposed to be 3 sec 3x 10 3x.
Yes.
3 how?
Because
Talking about that 3, June.
The derivative of 3x.
Yes, yes, it's because the 3 is at the Mafelojoni, reason being it's the last one to be differentiated. Do you see that? We're just doing step by step. Is it,
okay.
you're saying that sec of 3x, right? The derivative of that will be, you differentiate this function first, isn't it? Then, and leave the inner function the way it is. So that's sec 3x times 10, 3x. Then you differentiate the inner function, which is times 3. So it's this 3 here. That's what you're saying. So you can rearrange it and make it 3 sec of 3x times 3x. That's what you're saying. Isn't it? Yes, no. Hello. Hi.
Yes, ma'am.
Dango. So then this is equals to, there's a 3 times it, 3 times it's 2 there. What is that? 18. Right? And then the sec here times the sec here. So that's sec squared 3x times 10. 3x. Are we together? Yes or no?
Yes.
Yes, we're
Yes, ma'am.
together.
Donkey. Okay. So we're looking for the third derivative, meaning we're not done yet. Now, at times I can tell you, go and find the derivative number 1200. I'm just saying, might be in the exam. Doesn't mean you have to go into differentiate until 1200. Just putting it out there. Guys? If I say find derivative number 1200, are you going to differentiate the function up to 1200?
No, ma'am.
What are you going to do? That's your homework. Okay, how do we differentiate this one, Gare? There are two ways of doing it. There's a hard way or an easy way. Give me the hard way or the easy way. What do we do in this case? Someone talk to me, please. Guys, talk to me.
You can use product rule.
Okay, is that the easy way or the hard way? Okay, let's use product rule. So it'll be what? Let's use your product rule. So d, the third derivative over dx. So it'll be what? The person who says product rule, let's do that. Or please help the person who said product rule. Guys, if you keep quiet, I have a bubble gum here. And true. And it's very nice. And the sweetness doesn't even leave very quickly. Just know. I won't say the name of the bubble gum because they don't pay me to advertise. Guys, talk, otherwise I'll bubble. You said we're using the chain rule. Let's start there. I mean the product rule. Let's start there.
So it's gonna be 18.
Okay.
18. Yes. And multiplied by, we're gonna differentiate that sec squared 3x.
Okay,
we're
so
gonna say
then
multiply by 2.
Yes.
And then times sec 3x
Yes.
multiply by sec 3x times tan 3x times 3.
Mm-hmm.
And then multiply by tan 3x.
Okay.
Gonna be
Then
long.
ah,
And
you
then
chose it.
plus. No, I didn't choose it. I'm just helping.
One choose. Alice choose.
Okay,
One
and
choose.
then
Alice choose. We are like sheep. One
plus.
sheep goes down, we all go down. Plus.
Let's use a big brackets there on 18, just after 18, so that we can be able
Big
to
one.
see the difference. Okay, yeah, it's like that. Then plus tan 3x.
Okay.
Wait.
Mm-mm.
No, it's times sec squared 3x actually.
Sec squared 3x. Mm-hmm.
X and then times sec squared 3x times 3.
Okay, let's simplify this. My second years don't use a calculator. Let's see if you can use your brains. Good people. 18 times 2 times 3.
It's gonna
You
be
chose
108.
Hmm?
108.
It's 108.
108. Okay. Then you have sec times sec. Then you have tan of, okay, what am I saying? Sec to the power of 3x, because it's sec times sec. Then you have tan times, this is 3x, ne? Then you have time, then
Yes.
you have times 10, 3 x squared. Then you have plus 18 times 3.
Sorry, why says power
What?
3?
It's gonna be 54.
64 sec
Mm.
to the power of 4
Yeah.
3x.
54, ma'am.
54.
Yes.
Yes.
54. Okay.
So, ma'am, the 108 sec to the power 3, isn't it sec to the power 2? Or maybe I'm missing something.
Yeah, sec to the power of 2. You're right. All together, guys.
Yes,
But
ma'am.
Yes,
notice that it looks way different from the one in this textbook. Because in the textbook, they use the identity. Guys,
Ma'am.
I'm saying, do you see the difference though?
Ma'am.
Yeah.
Yes.
Yes.
Yes, I'm listening. Someone saying, ma'am? Yes, I'm listening.
I don't know. Can we simplify it even further?
You want to simplify it further? You can simplify it further. You can simplify it further. And how do you simplify it further?
By taking out 54.
Okay, let's not take out 54 for now.
Okay.
Guys, can you make it look like the one in the study guide without using the identity? No. Yes, isn't that in the study guide they used the identity to simplify? Do you see what they did there? Hey guys. In the
Yeah.
study guide here, they said 18, 1 plus 10 squared 3x times 10 of 3x. So then it gave them a nice one, which was 1810 of 3x plus 1810 to the power of 3 of 3x. Unlike ours that we had to do all these shenanigans. But we're not saying we are wrong. We're not saying we are wrong. Just saying simplify it. Because if you follow the textbook, then it means that there's something you don't have to look at the textbook. If something feels right, because what we did here to us felt right, or did it feel right only to the person who was mentioning? Hey guys, or it also felt right to you? Did it feel right to you as well? Guys, did it feel
Felt
right?
man.
So it felt right. Okay, let's do it then. Let's not look at the one in the textbook. We did it. We felt right. Now let's simplify this so that it looks like the one in the study guide there. Unlike the whole quotient rule, we could have just, but let's simplify this and see if it looks like the one in the study guide. How can we do it? Guys, let's think. You need to build things underwater at some point. You guys need to build something. If you don't think now, I won't trust the bridges and everything that you guys build or you guys created as engineers. So let's think. What can we do so that it looks like the one in the study guide? Because we use the different approach. We're not wrong. We're not wrong. Because it felt right when we were doing it. So I just want us to simplify.
Can't you also use identities here on this? Going further.
Way.
Like that sec squared 3x. And make it 1 plus tan squared 3x.
Can I give you guys a clue?
Please.
Can I give you a clue there?
Yeah.
In the textbook, there's 54 there. Do you see 54? Right? And the 54 has to remain with the sec. So it means that sec to the power of 2. And you can see that 54 plus 108, what do you get? 54 plus 108.
162.
So which one are we changing so that we get the 162? Guys, which one are we changing?
The one on the right.
Thank you. Thank you. The one on the right. Remind me the identities of 10. What is the identity of 10 squared? Guys, do I have to remind you?
Sec squared x minus 1.
6 squared is equals to?
For tan squared, sec squared minus 1.
Guys, did you claim the identities?
Yes, ma'am.
Okay, which one is the identity that you remember the most? So maybe it can help you to find the identity that you are looking for. Who's talking? Which identity do you remember the most? Can someone tell me the identity they remember? The one that never leaves their heart.
Squared equals to 1.
Thank you. Sine squared x plus cos squared x is equals to 1. We all remember that identity. Now, please mute. Yeah. We all remember that identity, isn't it?
Yes, ma'am.
Yes.
Yes or no? For me to get
Yes.
tan, for me to get tan, do I have to divide both sides by cos or both sides by sine for me to get tan?
Both
By
sides
cos.
by cos.
Yes, divide by cos squared x, divide by cos squared x, divide by cos squared x. Don't cram your identities. You know this will be what? Tan squared x. Cos squared x divided by cos squared is 1. And then this is what? This is sec squared x. Now you remember. Do you see that the one you always remember can help you to find the identities? Are we all
Yes.
together?
Yes.
Always go back to your basics. So meaning that tan squared x plus 1 is equals to sec squared x. So we can come here and say this is simplify further. Red color, please. So this is 108 sec squared 3x times 10 squared 3x plus 54. We know we have sec squared x times sec 3. Oh, gosh. Sec sec squared 3x. So this is equals to 108 sec squared 3x times 3x plus, we can change one of the sec here. So this can become 54, what, 10 what? 10 3x squared plus 1 times sec squared 3x. So this is equals to 108 sec squared 3x times 10 squared 3x. So this becomes 1 plus 54, 10 squared 3x times sec squared 3x plus 54 sec squared 3x. Then you can see this is the same as that. So this is 160 what? 162 10 squared 3x times sec squared 3x plus 54 sec squared 3x. Do you see now it looks exactly the one in the textbook? By simplifying that.
Yes.
What was the point of me doing that? The point is that, guys, if you remember your identity, you don't have to do 50 million steps to come to the same answer. Makes senses.
Yes, ma'am.
Bio donkey. So example 2. Let's go to example 2. How many minutes? We still left with enough minutes to do example 2. Okay, example 2. There it is. Z is equals to xy and y is a function of x. Find the following, Find the following. Find dz or dz, the derivative of z with respect to x. Can someone give me the answer quickly and immediately with images? Guys, quickly and immediately with animations.
dz over dx equals to 1 times y dz over dx dy. No, dx. And also say plus
1 times what?
y is gonna be y dz over dx.
Y dz over dx.
Because we are differentiating a y.
So you're saying what? Dx over dy, something like this. Are you saying this?
No, dz over dx.
dz over dx
Yes.
times dz over dx
Yes.
times dz over dx.
Then plus plus x. No. I made a mistake here, ma'am. Let's erase.
Where do I erase?
Just erase dz over dx of y. Yeah. Then we say plus x y times y dz over dx.
Times y dz over dx.
Yes.
Okay. Anyone? Do we all agree? Yes or no?
Ma'am, I've got
No.
a
The
question.
dz dx must be for x.
The what?
I
The
think
y.
Okay.
Okay, let's start with the lady. I hear a voice of a lady and then we come to the gentleman.
Okay, ma'am.
Yes. The?
I was saying the dz over dx, the one for the where it's in front of y.
Yes.
It's supposed to be dy over dx of x. The y is supposed to be alone.
The y over dx like this.
I think so, but on in front of x.
In front of x. And then the y.
Between x and y. Oh, can I do my line? Because I've
Okay,
changed
your
it.
line.
Yeah.
Okay, so dz over dx is equals to?
We differentiate x, so we're gonna have I think it's gonna be 1 plus y. Is it 1 times y? So times y plus x dy over dx. Like that. I think so. Not sure.
Not sure. Not sure. So I'll put a question mark here. Not sure. Number one, are you sure? Number one, are you sure?
Yeah.
100. How many percent?
Yeah, I would say maybe 90%.
90%. Sure. Okay. Then there's a gentleman who said something.
Oh, yes, ma'am.
Yes. Were you
I'm going
asking or were you
for-
saying?
Okay, before I can say my part, I want to ask for the number 2. Is that a 1 plus y or it's 1 multiplied by y?
One multiplied by y.
For me, ma'am, I'm agreeing with number 2.
Why?
The reason why I am agreeing for number 2, in my own view, I think I saw an error in number 1 there. Whenever we are differentiating implicit functions,
But this is not an implicit function. Be very careful.
When we're differentiating y there, ma'am, that's what I'm trying to say. We differentiate it the same way as x, but we don't write y. I don't know if you get the sense of it.
Okay. So if I wrote it like this, am I wrong?
Well, yes, ma'am.
Why?
Because it's y. You must it depends, ma'am.
On what?
Let's say like it was
There's a Mr. Depends.
The function was y, like f is equals to y squared, right? And we are supposed to differentiate it. What we'll do, we will say 2y dy over dx. Is it right, ma'am?
So if I had z, so guys, z is equals to y squared. And I said find dy over dx with this question. So you are saying that dy dz over dx is equals to 2y dy over dx. That's what you're saying.
Yes, ma'am.
Guys, can someone say something? There's something here. Why
Ma'am?
not number 3? Yes, please. Why not
Ma'am,
number 3?
for if we're doing this equation, ma'am, and we're using the product rule, it doesn't make sense to not have two of them, like y plus x, because we have to differentiate for both of them. So the y only doesn't make sense.
You know, at some point it does make sense.
I think it's because we are told that y is a function of x. So then z becomes
Done. Well done. Do you see that, guys? Because we are told that y is a function of x. They might not, maybe y at some point, y is equals to sine of x squared. We don't know. But we are told that y is a function of x, meaning that we have to differentiate it. Therefore, number 3 is not right. Number 1 is not right. But I think number 2 is right. Because we are told that y is a function of x. Therefore, dz over dx is equals to what? Is equals to y plus, sorry, the derivative x times dy over dx. So meaning number 2 is what? Number 2 is correct because we are told that y is a function of x. In implicit differentiation, we know we cannot write y equals to something, but we know that y is a function of x. Are we all together? Yes or no? There's something called partial differentiation. When you do partial differentiation, if you're going to, they write it like this, partial z over partial x. This, when you say partial z over partial, you keep the other variable constant. So meaning that it will only be what? It will only be y. That is partial differentiation. That's something that we'll do in future. But here they are telling you that y is a function of x. Therefore, you do what you do in implicit differentiation. Every time you differentiate y, you need to multiply by dy over dx. Make sense, guys, or not? Am I confusing someone?
Yes, it makes sense, ma'am.
How many yeses am I getting? Not from the same person. You can't vote twice. I put a mark on your yes so that you don't come back and vote.
yes, ma'am.
One more yes.
Yes.
Yes. So it will make clear, it will become crystal clear when you do partial differentiation. Just remember, put this in your mind. So as soon as they say y is a function of x, just know you have to differentiate it. So therefore, that's what you guys were saying. It's a product. Therefore, I do the product rule. So that's then dz over dx is equals to y plus x dy over dx. Now, what's the second derivative? They're looking for the second derivative there. Z over dx squared. So then we know that this is a function of x. So then this will be dy over dx plus dy over dx plus x d squared y over dx squared. So this is 2 dy over dx plus x d squared y over dx squared. Are we all together?
Yes, ma'am.
Yes, ma'am.
Yes.
Dango. I think example number 4, you'll do it by yourself, But let's do it example 3. Sometimes you might ask to prove. They say that if they give you y is equal to sine AT and x is equal to cos AT, then find the values of this. You might have to be asked to do that in the exam. So where do we start when it's like this? Let's go and see. I put my bubble gum here. Yes. So now, where do you start when it's like this? What are they saying? Yeah? What are they saying? When it's like this, what are they saying?
They're practically saying that we should find the second derivative of y is equal to sine AT and also the second derivative of x is equal to cos AT.
And then what with those derivatives?
And then we add them.
There's something you're missing there. So you find the second derivative of y and you find the second derivative of x, then you add them. Look properly.
Then you substitute. Then you
Then you
substitute
square
them
them.
on the.
Yes. You square them, then you add them. Guys, I want you to get full
Yes.
marks. I want you guys to get full marks. For as much as I want everyone to pass, not everyone to pass because some of you don't want to do their part. That's it. Simple as that. Nothing is difficult. So we have, so they want us to find the second derivative. What's going on now? What is this now? Eh? Okay, let me just make it small because there we go. So let's see. So we have y is equals to sine of AT. Let me see if I do this one by myself just to see. Then they want the second derivative, meaning I have to go say dy over dx. Why am I saying x dt? Because it's a function of t there. So then this is equals to cos of AT times A. So this is equals to A cos of AT, cos of AT. Am I right, guys? You're my teacher now.
Yes,
Correct.
ma'am.
So
You're
then,
right.
so then we have so then we have x is equals to cos of AT, then dx over dt because it's a function of t. Now we know that when we find the derivative of cos, it becomes the negative sine of AT times A. So this is negative sine, negative A. I forgot the A. Negative A sine of AT. I'm not done because they wanted me to find the second derivatives. So let's go do that. So then this is the second derivative dt. So I know that when I differentiate, so this will be a times negative sine of AT times A. So this is equals to negative 8 squared sine of AT. Then dx squared of dt, forgot squared. So this is minus a cos of AT times A is equals to minus a squared cos of AT. So now they say square them. Okay, let's square them. So we know that this, we need to square it. So it's square y d t squared, square it. Guys, hey, maths is nice. They just tell you what to do. If you remember everything, it becomes nice. Then this, if you square it, this becomes a to the power of 4 sine squared of AT. and then square this one. So this is d squared x over dt squared, so squared, negative squared, at squared. Now my brain is playing. So a to the power of 4 cos squared at. Do you see that? After squaring, you add. That's what they're saying. So you add the squares. So let's add the squares. So they're saying that you say d squared y over dt squared plus d squared x over dt squared. So you have added that, right? Which is now substitute. So a to the power of 4 sine squared at plus a to the power of 4 cos squared at. Now, from here, what can we do?
We have to take out the common factor.
Yes, I hope there's no one who say they can't take out the common factor, because we did taking out. If you take out here, take out there. That's what we call common factor. What is the same? So you take it out, you put it here, you close the door, there's nothing you can take out, then you left to sign. Okay, why now? What are you doing now? Why? You see now, okay, this is okay. Let me just take out there, and then you're left with sine squared at plus cos squared at, a to the power of 4. Do I leave it like this? What do I know about this? This is your favorite identity. I know.
Yes, which
You're
is
going.
equals to 1.
1.
Yes, I knew it. You'll scream. So this is equals to a to the power of 4. That's your answer. Did you hear that? And did you see that?
Yes, ma'am.
So last week I
Yes.
took few of your minutes, so I'm giving you back your few minutes. So I'll stop the recording. Any other question related to the work, so that we record, other people can see the question, maybe it might help them. If it's not related to the work, then say, ma'am, not related to the work, then we close the class and then you ask your question. Do you have a question related to the work? Example 3 is homework. Go and do example 3, guys. It's homework. We can't do it in 5 minutes. Example 4, I mean. If there's something there that is pushing you, like hitting you, putting you in the ring and boxing you, you let me know. So no question regarding the work. So I shall stop the recording. I hope I was recording. So goodbye, Mr. Recording. Oh Lord, I've pressed what? Hide meeting information. Stop the recording. Stop.